So this one is question number 7 in SC Verma, and in this one we are given the acceleration in terms of a graph. There is an x-axis and its acceleration is varying with time. First we have an acceleration of 5 feet per second square for 10 seconds, and there is no acceleration, and then again a negative acceleration of 5 feet per second square for another 10 seconds, and we are required to find out the distance traveled in this whole duration. We are assuming that the initial velocity is 0. They do not say explicitly, but it's a cart. It's saying that it's a cart and started at t equal to 0. So we are assuming that the acceleration is 0. If you look closely, this problem is the class 9th or 10th problem. It's not a class 11th problem. All you have to do is convert this graph into figures and apply one of the three formula that you have read in class 9th and 10th. V is equal to u plus at, v square is equal to u square plus 2as, and the distance formula s equal to ut plus half at square. And apply it in three different sections, and then you should be finding out the answer. So let's do this formula method real quick. For example, in this one, you can do s equal to ut plus half at square. So u is 0, initial velocity 0. So half at square is half into acceleration is 5. T square is 10 square, 100. So this becomes 500 by 2, 250. When it reaches this point, the velocity at this particular point is v is equal to u plus at, or at this point the velocity is 0, a into t, 5 into 10, 50 feet per second. Now at this there is no acceleration, so the velocity stays constant at 550 feet per second and it travels for 10 seconds in this duration. So the distance traveled will be s equal to u plus s is the distance traveled is simply velocity into time, or 50 into 10 or 500 feet. And finally, in this position, you can apply again the formula s is equal to ut plus half at square. U is, you have find out as 50 feet per second, which is here as well as here. So 50 feet per second square multiplied by time 10 seconds, half, acceleration is minus 5. So this is minus 5 into t square is 100. So this becomes 500 minus 500 by 2, 250. This is 250. So add all this is 250 plus 500 plus 250, 1000 feet. Your answer is done. But what we want to do is we want to solve it using graph only method. The graph method gives you an insight of what is happening and allows you to solve more such problems. So what we will first do is we will plot a graph of the velocity of this particle with respect to time. Actually, we are trying to plot the speed of the particle. We are assuming that it's moving only along the x-axis, and we are plotting the distance of this particle, velocity of this particle along this x-axis. So let us say this time graph and then this velocity graph. So when it's 0 here, the velocity is 0. Now think about how the velocity will move in the first 10 seconds. It's saying that it's 5 feet per second per second. What does that mean? Its velocity is increasing by 5 feet per second in every 1 second. If this is the second and this is the first second, its velocity will increase from 0 to this is 5. In the second second, it increases again 5 seconds. Again 5 seconds. And by the time you have 10 seconds, the velocity will have increased to 5 into 10, 50 feet per second square in a linear fashion. This is the velocity, how it's varying from 0 to 10 seconds. At this point, there is no acceleration. and there is no acceleration, anything that moves will keep moving until an external force is applied, and here we have applied the external force to the body, and its velocity will start decreasing for this moment. This is at 20, particle is like this. Now here we have a deceleration of -5 feet per second. So whatever this velocity, which is 50 here, we will start decreasing to 45 feet per second in the 1 second, again to 40 feet per second, and so on and so forth. When it reaches here, its velocity will be reduced to 0 feet per second. You can calculate it as from the formula v is equal to u minus 80, because acceleration is negative. It was 50 minus 5 into 10, and that is 0. This is the velocity at this point. Now to find out the distance traveled, what you do is you just find the area of this graph. And the area of this graph is, this triangle is half into this base 10 multiplied by its height 50. Half into 10 into 50 plus area of this graph, which is a rectangle, 10 multiplied by 50. 10 into 50 is 500 plus half of base into height. Base is 10, height is 50. This is 250, this is 500, and this is 250. The total answer is 1000 feet. The graph method gives some more insight. The second part is draw position time graph. With this is given, we need to find out the position graph. This is time, this is position. The particle starts from here. Its velocity is varying with time. So the position will be given by s is equal to ut plus half a t square. Initially the velocity is 0. So ut becomes 0, and we have half a into t square. It will be a function of the square of the time. The distance reached here is 250, so I will make a distance 250 here. And because if it is varying with the square of the time, the graph will come something like an exponential. It will vary exponentially like this. And in this position, the velocity is constant. So the velocity is constant, so the distance will vary with time with a formula which will be a linear function of the time. This is 250, this is 500, something like this. And finally, in this part also, the distance is still increasing, and that will again increase, which will be proportional to the square of the time. But we will also have a factor of ut here, and therefore this graph will also become something like this. So this is the kind of the graph you will see of the distance.